We are live now.
Okay, cool.
Monica, you can start with the intro.
Yeah, sure, Shakti. Okay, so starting with a very warm welcome. We're very happy to welcome you all for our 86th edition of Geek Night. So we would really appreciate this session to be very interactive. So you can ask your questions, or even you can pour your questions in the question QA box, or you can raise your hands so that we can able to answer then and there. Okay, so without any further ado, let's get started. So we have two talks for this evening. So starting with our first talk by Sivakumar Palani, who is a technical lead at Cisco Webex Calling team. He's going to present evolution of microservice architecture and DevOps. So over to you, Sivakumar.
Okay, great. Thanks, Monica. Let me share my screen.
Yeah, sure.
I hope everybody able to see my screen, right?
Yep. Yeah.
Okay. Okay, great. Thank you, guys. Thanks for joining today Geek Night. So today, the agenda for the talk that I'm going to present is about evolution of the microservice architecture and then the DevOps. So the reason why we just want to share. So right now, microservice architecture is one of the key phenomenon in the software industry, and also in terms of the deliverable and the CA and then CD, you should know what the DevOps does. Okay, so in this tech talk, I will try to cover as much as I can. So these are the just a minute, some issue the keys. Okay, so these are the agenda. So if you look at here, the agenda probably has close to 8 topics. So just at the time of interest, we cannot go through in detail about each and everything, but I will try to cover as much as I can. And if you have any questions, if you have any clarification, please let me know. If possible, we will try to address. If not, probably you can reach out me. I've shared my LinkedIn profile as well, so I'll be active on my LinkedIn, so you can reach out me. Okay, so without further delay, we'll just get started. So first, we'll look about the microservice architecture. Okay, so before we just deep dive into the microservice architecture and what it is, first of all, let's try to understand the principles of the microservices. So why microservices is something different than what it has been there in the architectural design, right? So when we say microservice, so the microservice should be built around the business capabilities. So what that means is when you are doing architecting your application, you should come up with your design or the problem around the business capabilities. So that is what microservices, and then each microservices should be independently deployable. Each microservices should be loosely coupled between the other services. So to relate exactly in the software terms, in the software industry, we have a typical 3-tier architecture, right? So where we probably have a front end, and there will be one big giant monolithic application, and then there is a database. So that's a typical thing. So but with respect to microservices, you have to divide your big problem or a big domain into the subdomains, and then each subdomain you can relate that into the microservices. So when you say microservices, the microservice 1 and then between the microservice 2, it should be loosely coupled. There should not be a tightly coupling. And when we say microservices, each microservice can be as its own language. So in typical monolithic architecture, if you are writing application in Java or Golang or Python, so the entire application module function, everything that has to come around the single language, because you cannot have a one set of functionalities on the Java and then one on the Python. But in terms of the microservices, you choose which programming language that suits for that specific microservice. And with respect to the microservice architecture, you should have each microservice as its own database. So when we say database, it could be a SQL or it could be a NoSQL. So it depends on what it is. So if it is a transactional based data that has been processed through your application, then you can think about some of the RDBMS, relational database. If it is a non-transactional based, I'm just giving a use case. So then you can go with the Mongo or any other NoSQL database, and even there could be a microservice which does not even have a SQL or NoSQL. It can have an in-memory database like AWS, Redis, and there are a lot of things. So that's the pure advantage of having the microservices. When you say microservice for a specific service, what architecture, what programming language that you have to choose, and you have to build around that specific problem. Okay, so now let's look at a little bit about the microservice architecture. So in the right hand side, you can see there is a software architecture, and then the left hand side there is an infrastructure architecture. The thing what we have seen in the industry is most of the products or the applications or even the industry, they put focus on the software architecture. So there are a lot of good things around the software architecture for us to design our software around the microservices. For example, you can use a domain-driven design. So for us to understand, you can go and look at what it is, and there are a set of principles that you need to follow. And there are a lot of other options like CQRS. It's like a command query responsibility segregation between the microservice, and there is a way that functional reactive programming. So the point which we would like to highlight here is the focus more goes onto the software architecture, but it's equally important that we put the focus on the infrastructure architecture as well, because it's equally important how your infrastructure that's going to look like for your microservices. Until and then, if you don't consider during your architecture, during your design, then even though you have a beautiful programming language, beautiful design principles that you have it, but if your infrastructure does not support, you cannot scale your application. So that's why it's really important in terms of the microservice architecture. It should be a balance between both software as well as the infrastructure. So in the infrastructure architecture, you should know how do your how are you going to expose your microservices to the outside world? What sort of the API gateway mechanism you are going to put in within your different microservices, and how each microservices that is going to intercommunicate. So those are the things should be considered during your architecture or during your development phase. It's not just on the software architecture you put a focus, and it doesn't mean you have done a great job of doing the microservice development. That is not the case. So that's the point that we would like to highlight. So now the next thing which we want to touch up is how do we smoothly transition from the monolith to the microservices. Okay, so the good thing is around the microservices, it's if you are typically starting your application from the scratch, or if you are building application from the start, it will be easy for you to go around the microservices principles and what are the best practices that you need to follow. But the big challenge is you have a big enterprise applications which is already architecture to the monolithic architecture pattern. But how do you transform your monolith to the microservices? That is the big challenge, and that is what we are going to look at in the how are we going to convert from monolith to the microservices, and what are the pain points of having the monolith architecture. Okay, so the other thing which we need to know about is the typical financial institutions or well reputed product companies. They have the products, or they have a lot of solutions in the industry that's been there for a while, like it's been there for 15 to 20 years, but those are all very complex application. There is a single database. If you look at it, go and architecturally look at it, there will be close to more than 150 tables, lot of stored procedures, right? So the question as a technical architect, how do you transition from the monolith to the microservice? So that's the thing. So with typical monolith, let's try to understand some of the problem what typically we face, right? So with respect to monolith, if you look at this diagram, it clearly says that there will be a set of different teams, like the team A, B, C, and they are co-located across different regions, and they are all working for a single product. Okay, so let's assume this is some a consumer retail product. in that case, if the team B is making some enhancements out of the pricing service, and if they introduced some issue, then the whole product which will cannot deliver to the end customer, because that's the big pain with respect to the monolith. And also with respect to the monolith architecture, if you want to scale specific service, let's assume there is a Diwali festival, okay, and as a product owner or as an end customer, you can expect there could be a lot of load, or there will be a lot of usage on your specific application. So since as an architectural guy or engineering guy, you know what sort of service that you need to scale. For example, if you log into the amazon.com, there could be a lot of load on the payment service, there could be a lot of loads on the order service, but there could be a very load on the report, or there could be very load on the review compared to the the load which is going to have it. So in that case, you need to think about how are you going to scale your payment service, right? So those things with the monolithic you cannot scale. So that's the another problem. If your customer comes and says, I want to scale my applications to the 2x for the pricing service for this month, you cannot do it, because everything is a single application. You just deploy it as a single var jar or whatever the technologies that you use. So now having these all of these pain points, then how a lot of industries they were able to successfully convert from the monolith to the microservice, what sort of path that they do. So that's where the Strangler pattern comes into the place. So Strangler pattern is another design principle which will help us to smoothly transition from your monolith to the microservice architecture. So in this diagram, if you look at here, so in your retail project, if you have a lot of modules or a lot of functionalities around the product, so the Stranger pattern comes and says that instead of you try to convert everything on a single day, like you cannot practically convert everything in a single search to the microservice architecture. So if you try to do it, you will definitely fail. That's the the industry lessons what we have learned out of it, right? So the pattern what Stranger says, out of your monolithic big complex application, try to see which sort of functionalities or feature which is very less used by your consumer or a customer, which is less criticality. Try to convert that sort of functionality to the new microservice architecture and see how that works, and let's have that as a separate pipeline, and let's the remaining functionality works with the monolithic and see. So that's how you can smoothly transition, right? So here is the Stranger pattern which says, right, so for example, in the earlier days, like typically you don't have a microservice architecture, you have a only monolithic architecture, right? So what happens, there is a customer, whatever they try to use your product, all the requests will be routed to the legacy application, and there is a Stranger pattern which will help us. Instead of you try to convert everything to the monolithic, you just try to convert one of your monolith or the legacy functionality to the modern microservice architecture. Let's route both the requests. For example, 60% of requests, let's go to the monolithic. Only 40% of the request goes to the modern microservice architecture, and see how that works. Are you able to, successfully transition? If that works, then slowly one by one, you sort of convert everything, and then you, at the end of 2 year or 3 year down the line, you have converted all the functionalities into the microservice architecture. So that's why this Stranger pattern is really important, especially if you are trying to convert from monolith to the microservice architecture. And now we look about some sort of RESTful guidelines. So for what we were discussing is around what is microservice principle, why we have to put a focus on the software architecture, and also it's equally important that we put the infrastructure architecture as well. And also we have seen how do we convert from monolith to the microservice architecture using the Strangler pattern. Okay, so now the portion is around the RESTful guidelines. So on the end of the day, even though if you develop microservices, irrespective of any languages that we use, at the end of the day, we are going to expose as an API. So when it comes to the API, it probably most of the day nowadays we use REST, Still, there were companies still they use SOAP. We don't want to get into that, but for now, if you are building a REST APIs on top of microservice architecture, so these are the guidelines you should know. This is what industry is also following. Okay, so when you develop a REST API, there should be a proper documentation should be there, and there should not be a differentiation between the APIs that you have developed and what is the API that is exposed to the customer. For example, what typically happens in the real-time use cases as a dev team or engineering team, we used to go and enhance the existing API, but we forget to modify the API specification. But whoever consumes or whoever refers our API, they feel that that is not up to date. So this RESTful guideline says your documentation should be up to date. That's why instead of you manually writing the documentation for your REST APIs, there are a lot of open source tools, and there are a lot of ways that you can generate the REST API documentation out of your code, so that whenever any team makes the change, your documentations also get updated. Okay, so that's important. And the other one is the pagination. So typically, all the REST APIs that we expose, especially on the Git, it should have the pagination support. So what is mean by the pagination? If you are not aware of it, let's assume if you are logging to the system and that system has more than 1,000,000 users, okay, and you are trying to navigate to the users page and you are an admin user, okay. So instead of you are trying to get API and then go to your system and getting the 1,000,000 users as a single HTTP request, this pagination says that by default from the REST API recommendation, I will provide first 10 APIs. It could be there are a lot of things you can get into it. When it goes to the pagination, you can do a sort by ascending, descending. What are the fields? If it is a web page or a mobile app, how do you want to have it? But that is recommended. If you don't have the pagination, by default, if you return everything to the client, let's assume the thing which we want to make sure around the architecture is we don't want to put a override on the client, whether if it's a JavaScript application or it's the mobile application. You don't even know whether the actual end customer will navigate to the all the user page. So that's why it's recommended that you have the pagination in your REST API principle. And this is a good example of Google. Like in the Google also, if you go and try to search anything around any contest that you are trying to search, you would see around 1,000,000 results that is found for your search what you have tried in the Google. But by default, Google will give you around 10 to 15 results. It doesn't want to give all the results, but it says there is these many relevant contents, right? So that's a good thing that we need to follow. And then with respect to REST, you need to use SSL. SSL is the security. Security is very, very very key phenomenon to have it in your REST API. If you don't properly secure, when you say secure, there are a lot of things you need to think about. What sort of authentication that you are going to have it for your REST API, and what sort of the authorization that you are going to have it. So those are the things you need to have it. And if you want to deep dive into the security, there are a lot of things. Are you going to use OAuth, OpenID, LDAP? There are a lot of things that you can think about for the microservice architecture. But the thing is, you should secure. There should not be a situation where somebody who doesn't even have a proper access, they should not get and access to your API. So that is why it is important that you secure your APIs and then use the proper HTTP methods. So this is also one of the good thing that we need to follow. There are a lot of methods, but for example, Get is something that from the resource you are trying to get some results. So there should not be a get, but it internally goes and updates the database. So if you have seen a system or if you have seen an API that follows that principle, then that's totally opposite to the what REST recommends, right? So, and also we need to use the proper HTTP status codes. This is also one of the key thing. You need to have proper HTTP status codes. So what that means, if you are writing a HTTP REST API, if it is a client side error, okay, then we need to return the 400 series error codes. What that means, when we say client side error, there is an error, the person who is submitting the request for your REST API. Okay, it could be a 401. What 401? It will say 401 is the unauthorized So it means somebody trying to access your API, but that person is not having access to your resource, but he is trying to access. So your system has to return 401. And if somebody trying to access your resource with the invalid URI, then you will say 404. It means by default it is not found. And there are a lot of things like a 403 is a forbidden. There is a API that you want to delete a user. That delete user is only allowed for an admin sort of rule, but the normal user tries to delete the user API. So you will return the 403. So those are the 400 series sort of error code that you should properly handle. It is not, or it should not have a REST API implementation that whatever error happens in your system by default, you should not return 400 or it should not return 500. Now I'll come back to the server side data. So when we say server side error, that is the 500 series. So there are a lot of things. I think if you are already in the software industry, like the 500 is the internal server error. Something happened within your application business logic that you have written. For example, there are multiple threads trying to access your piece of block that you have executed, then probably concurrent modification exception can happen on your API that you have exposed. So then that is 500 internal server. 503 is a service unavailable. It means your service is down. If a microservice A calling microservice B and then microservice B is no more available, then you should have the 503 as a service error code. And similarly, you should have a proper HTTP status code so that you have it in a proper thing. And then the one which you need to take care about the RESTful guidelines is about the versioning. So whenever you expose REST API, the recommendation is you should have a versioning. So version 1 and then version 2. You have to slowly move from version 1 and then version 1.1, and then if it is a major change, you change it to the version 2. I don't know, like all of you know, looked at the open source API. Like if you go and look at the Google API, Amazon AWS API, so they have defined their API with the versioning. So what that says is, when you are designing your API, so that API by default will start with the version 1. And if you are doing the major change, then you have to provide the version 2. So if there are consumers which they are using your REST API, and you cannot on a single day to transition from version 1 to the version 2. So there should be a backward compatibility for the version 1 for a certain period of contract. Then you slowly communicate to your consumers that we are slowly converting all our version 1 to 2. So those are the things you should think about, especially on the RESTful guidelines. Now I'll just move to the next topic. I think we have a lot of things to cover. So the next topic is around the Apache Kafka. So now why do we need to know about the Apache Kafka? Okay, so now we have seen the microservice architecture and then principles and then REST API guidelines, right? Now when we say microservice architecture, it's a good thing to know how the microservices will intercommunicate, because when you deep dive and look at the architecture big picture, there will be a lot of microservices which runs behind the scene, but all of the things will coordinate together and it will return a system. For example, in the real-time use case, if you go and log into the amazon.com and if you are trying to do such an order, you are trying to search a product and you are trying to place an order and you're buying that product. So as an end customer, you are trying to do, or you're trying to relate, there are 2 or 3 operations you do it. But in the behind the scene, if you look at the AWS architecture, it could be more than 100 microservices which coordinate, right? For example, notification service, it could be a payment service, there could be a user service. There are a lot of things will be there. So here the point is how each microservices will intercommunicate is the key thing. Okay, so there are 2 ways typically the microservices can intercommunicate. One is on the synchronous communication, and then the other one is as the asynchronous communication. So when we say synchronous communication, is microservice A directly calls microservice B through the HTTP call. Okay, so when we say, since it's a synchronous communication, since the call is happening through over the HTTP, the caller has to wait for the other service to return back until, and then the service A has to wait. So that is the synchronous communication. So when we say asynchronous communication, the microservice A trying to put some sort of message into the common medium, or a broker, and whoever wants to listen to it, and they will listen to that message, and in the parallel they will do the processing. For example, let's assume if you have a use case where you want to generate a report on every day, how much uses or how much usage on your product. I'm just giving a use case. Okay. So for this, there is a functionality in your product where there is a generate report. And whenever the customer comes and clicks on generate report, it doesn't mean you have to generate a report on the same day or on the same time, right? So there could be a bulk operation that can happen on the behind the scenes. So those are the things is what the asynchronous messaging. Okay. So now the point is, so in the microservice world, for us to do the inter-service communication, there are a lot of messaging queues that is available in the market. So there is like, to call out some of the things, there is a RabbitMQ queue, there is an ActiveMQ queue, and so on. There is for us to communicate between the microservice. But having Apache Kafka as a messaging queue between the microservices, which will help you to scale your inter-service communication, right? For example, LinkedIn is one of the company who is sort of founded this Kafka, and then they come given back to the open source community. So if you look at the LinkedIn usage, Kafka for a per second, it's more than a millions of messages that is able to intercommunicate. So now to know the Kafka, let's try to understand a few core concepts, right? So the Kafka is working on the pub/sub model. So there will be producers who is sort of producing. So you can assume this is a microservice A and this is the microservice B. Instead of microservice A calls through the microservice B, so all the communication is happening through the message broker. So that's what the Kafka comes in, plays a role. Okay. So now let's try to understand why Kafka. What is the big advantage between the traditional queue or the pub/sub model, right? So with respect to the traditional queue, by default, all the consumers will put the message into the common queue, and then consumer will listen to the messaging queue and they will process it. What is the problem with the messaging queue is, if you have an ActiveMQ or RabbitMQ for your inter-service communication, you cannot guarantee when you do the asynchronous parallel processing. That's the problem. If you have a typical messaging queue, and then there is a pub/sub model where it says it will guarantee, if you do the asynchronous parallel processing, there will be multiple consumers. It will guarantee that the order of message that comes into your pub/sub model, it will deliver. But since the pub/sub model does not have the partition, you cannot scale if you have large volume of data. So that's why Kafka is combining the queue where it is able to partition the data. You can partition the data into the multiple server nodes so that you can scale. And also, since the Kafka is working on the pub/sub model, it's able to make sure that even there will be multiple consumers, and even if you do asynchronous parallel processing, it will guarantee the order of message that came inside your queue. It will delivered with the same order. Especially the Kafka is another one of the big major feature that you can think of is the live stream. Wherever you have application where you want to do a live stream, for example, Netflix and then YouTube, internally they have similar set of Kafka, live stream processing that is happening behind the screen. So that's why it's really important that you use Kafka. Now, I think we'll move to the next.
Shiva, I think we have a question. Someone has raised their hands. I don't see their name. Just
Okay, fine.
It is from Adnal. I think it is about service mesh.
Yeah, service mesh is one question, and the other question is about there is a difference. I just wanted to understand the difference between the Kafka and RabbitMQ in terms of performance and all those things.
Okay, great. So the first question I will take it since we are talking about the, I think service mesh, we had to talk about it, but anyway, we'll talk it on the next slides.
Sure.
Okay, so on the queue and then the Kafka. So in the typical RabbitMQ, right? So the problem is when you try to put a message in the RabbitMQ, I don't know if you have a system where you do asynchronous parallel processing. There is a queue or there is a event that came inside your RabbitMQ, and then you asynchronously parallel process a lot of things, right? For let's assume there is a let's say create order something in the Amazon, and there is a lot of microservices which runs behind. If you do asynchronously, all the microservices has to parallelly process, then you will end up a situation where you cannot process the records, because there will be some inconsistency will happen, because that's a limitation. And if you want more detail, probably you can reach out personally also. But with respect to Kafka, it will be able to guarantee. And also, since this queue will not have the partitioning of the data, and also the major difference between the queue and then the Kafka is the live stream. In the typical active or RabbitMQ, there is, there are ways that you can do it, but the way what Kafka supports, the way the Kafka is designed and architectured is for a large volume of data to transfer, and especially if you are doing the live stream processing. So those are the things that you can very well use of the Kafka topics and how do you use it. So now, hopefully.
Got it. You pretty much answered the question. Probably I will dig in further that. Thanks.
Yes. I think now itself it's 6:30. I think I have a lot of things to cover. Probably I will rush through fast whatever I can.
Maybe we'll take the questions at the last. Is that fine, Shiva?
Yeah, probably we'll do that.
Cool then.
Okay. So the another one is, this is also one of the thing that especially on the microservice world, if you are something following up, the another good thing you should know about is on the service mesh. So service mesh is in a simple terms, it's like a inter-service communication infrastructure for your microservices to communicate. Okay, so what that means is having a service mesh within your microservice architecture. Each microservice will not directly communicate with each other, and all the communication will go through via proxy, if you know, like an Nginx proxy, HA proxy, some sort of things, right? The similar thing. So this service mesh is going to have some sort of a proxy between your microservices. I will go in deep in the next slides, but for now, let's try to understand the problem statement. What was the reason why microservice world is moving towards a service mesh? Why do we need it? What was the problem? Or we are good so far with the architecture or whatever the infrastructure we have, right? So the reason behind for all this question is, so when you have the microservice architecture, you have to do a lot of cross-cutting things, ad hoc solutions, right? So if you have typically microservice architecture in your application, you should know about how do you have the distributed tracing across your microservice. What sort of the security that you are going to have it? What sort of the traffic control you are going to manage between the microservices, right? So those things you need to know on the earlier microservice architecture. Having the service mesh as a concept, as a principle, which will address these cross-cutting functionalities. Okay, so now let's try to understand. Let's try to relate to the real world problem, right? So in the left-hand side, you guys are able to see it. This is the service architecture which is not having the service mesh. Okay, so here you can see there is a service A is a microservice architecture, and then service B, and then service A. Let's assume I have a 3 microservice architecture. So in the typical microservice world, for you to have the service discovery, if you want to handle the circuit breaking, right? So microservice will have circuit breaking as a resiliency principle that you need to handle the different error scenarios. So for us to have such use cases to handle, typically what you have to do is you need to come up with your own library or utility that you need to handle it. Each microservice you should have it, or probably you will come up with your application, within your application, whatever these for example, if you want to add a tracking ID in the microservices, right? Until and then if you don't add a tracking ID, the main big problem with the microservice is when you get into the real time is the microservice will go in deep and it relay, or it tries to connect, and it tries to talk to the different microservices. It will be 100 microservices. So if you don't have a proper sort of microservice tracking ID implementation, then it's really difficult for you to which microservice it's failed. From the end customer, it could be a single HTTP REST API point. So for all these things in the earlier world, we need to have library, whatever the mechanism that you are going to come up. So in the right hand side, if you look at here, there is a service mesh within your architecture. So all the microservices not directly going to talk to the other microservices. Instead, what it's going to do is it's going to talk to the sidecar proxy. You can assume it is sort of a some sort of a proxy or some sort of a tool which is open source, which is going to cut down all your cross-cutting functionalities. For example, if you want to rate limit your microservice, you don't have to do. So go to your sidecar proxy and you just do some configuration. And you want to do a circuit breaking. For example, service B, whenever it tries to reach to service C and there is a lot of failures. If it is more than 5 times failures, I don't want to make a call to the service C. Then don't write a code. Come to the service mesh and try to do a circuit breaking logic and you just do a configuration, right? So I'll just go a little bit deeper so that you guys able to understand. So service mesh under the net, it run or it build around the sidecar proxy or sidecar design pattern. That is a fundamental design pattern how the service mesh has been proposed. So if you look at the overall for understanding, you can just assume that this service mesh will divide into the 2 planes. One is the control plane, the other one is the data plane. So the control plane is the plane where in the service mesh you sort of come up with your rules and then whatever the configuration that you're going to do. And there will be a data plane that will get the rules configurations from the control plane to the data plane, and it will act based on the rules what we have configured. Okay, so in this use case, let's assume this customer microservice has to talk to the order microservice. In typical world, what we do is from the customer microservice, we'll make a HTTP call to the order microservice through the HTTP layer. So instead that, since we have introduced a service mesh or a sidecar proxy, so all the HTTP localhost call will go to this proxy, and this proxy will internally call to this sidecar proxy, and then it goes. Since all the inbound, outbound traffic goes through this network stack or this sidecar pattern within your server, then you will able to come up with your cross-cutting things. It knows which HTTP request comes. If any request comes, add a tracking ID. If there is a lot of failures, then it knows, okay, these many failures. It will try to do a retry. And if you have a traffic control, so let's assume in the typical use case, right? Let's assume I have a 2 sort of APIs, order version 1.0. This is the existing API, and there is an enhancement that we made, and that we call it as an order version 2.0. So in the typical world, we don't want to route all the traffics directly to the version 2.0. So there could be a traffic rules that we want to have it. Only 2% of traffic has to route to the order version 2.0 and see how it works. And then typically you just route all the traffics to this one. So for us to do such a thing in the microservice world from the end user thing, since you have service mesh within your microservice architecture or within your infrastructure as a proxy, you can do all this configuration. So that's why it's really important that you should know about service mesh. And to call out some of the things for you guys to go and look about is Istio. Istio is one of major open source service mesh sort of tool that you can think about, and there are a lot of things as well. Istio, and then there is an Envoy, things like that. If you just go and look about service mesh, everything you will come to know. Now,
Shiva, like time check, like it's 6:40.
Okay, then
Okay.
I think I have a lot of things. Okay, probably I will go for next 20 minutes. Is that fine, Saktivan?
That's fine. Just to add one more thing, if folks are interested in knowing about the Istio and the service mesh which she was talking, we do have like talks from past in our GeekNight YouTube channel. You can go refer there also if you're interested. Thank you, Shiva. Continue.
Okay, I think as I said, so these topics requires everything more than 1 hour session. So covering it in 5 minutes is cannot possible. At the same time, I don't want to throw some theoretical things, and you guys at least should have some understanding. So now let's go into the GraphQL. So GraphQL is another thing. If you are in the microservice architecture or you are building a platform for your applications, you should know about GraphQL as the thing, right? So now let's try to understand. So GraphQL is a graph query language. It's an open source query language on top of the graph data structure. So GraphQL has internally three things does. One is the reading the data, and then another one is writing the data, and then the third one is subscription data. If somebody observe that event, automatically send the data back to the event that they subscribed. Okay, so now again we'll try to understand the problem statement. Why the industry going towards a GraphQL? Okay, so with that, let's try to understand the limitation with REST API. What is the limitation? So if you build the REST API, typically we come up with the use cases and we come up with the resources and we will come up with the payload. This is the HTTP API and this is the payload and this is the contract you sort of integrate. Okay. And then eventually the use cases comes and eventually we start adding a lot of fields, right? And so there were use cases where from the mobile client, I just want to know only two fields. For example, I just want to know when I getting the users, I just want to know user image, first name, and then last name. But since REST API is designed around the resource in the REST API principle, if you get users is as username, first name, and then address, contact, everything, typically it will return all the things. So what will happen is over the period, you will end up seeing your REST API is bulky. And with respect to the REST, you will start using versioning for your REST API, then you will start using over usage. You will end up in a situation where you using a lot of REST API versioning. So now let's try to understand the difference between what is the difference between REST and then GraphQL. So REST is something resources managed by the server. You don't have any control on what data that you want it. REST is there is the resource or HTTP API that has been exposed. As an end consumer, you just consume those REST APIs that it will just return. You cannot say this is what I wanted. When we say GraphQL is come up with the query database engine. On top of you can specify the custom schema. So the resource is managed by the client. What it means is, let's assume in a simple use case, if I have a user as a schema, in the typical REST API, you hit /users and then it will return everything. In terms of the GraphQL, you define the schema that what field, what data I wanted for this API. So that is the best thing. From the client, you can specify the what fields you want it, and especially GraphQL is something is predominantly used by the Facebook. So Facebook is one of the big fan, and they were using the GraphQL. And with respect to REST, again, these things by the naming you can come to know. Right? REST you don't have control because everything written with the REST. GraphQL you come up with the thing, and especially the big advantage over the REST and GraphQL you need to know. Probably the more you deep dive, you will understand. But the another thing you need to understand is in the REST, you cannot fetch the relation-based data. For example, let's assume if you want to fetch the data, the user who accessed your product more than 50 count within the 2 months. I'm just giving some relational data. So in the typical HTTP world, if you are a consumer of users microservice, then you have to make a multiple calls. For example, you hit a user service, you get the list of users, and then there will be another microservice or another REST API which says how many usage which has some other billing related API. Then you combine the data, you aggregate, orchestrate, and you return back. With respect to GraphQL, you will sort of combine, you set up a schema, and you can join the relation-based data between what sort of the relation data that you want based out of a single HTTP call. So that's the thing. And just at the time of interest, I'm not going to talk about a lot of things, but if you are somebody.
So
Yes.
sorry to interrupt. So if you have a couple of topics to discuss, if it is possible, can we have a part 2 for the coming month? Will that be fine? Like instead of rushing through the topics?
The other topics are all not big thing, so I can able to complete in 15 minutes because these are the more on the architecture things. The other things are all should be okay. If anyone interested, probably we can talk about. Is that fine? Because those are all like things to know. It's not something that you guys. Okay. I'm going to deep dive. Okay.
Okay. Cool.
Okay. So the another one. This is also interesting. This says, chaos monkey, right? This is around the microservice, the way the industry is doing a lot of experiments the microservice testing, right? The name itself interesting. Why this name comes in, right? Let's assume there is a room, there is a server room that there is a monkey that is entered into the server room. It just randomly plugs out the cables of your typical critical infrastructure architecture as hosted in that server room. Okay, then as a service engineer, you should know, or you should come up with your design. Even though the monkey randomly plugs out the cables, the remaining service or the remaining system should work as expected. So that's the name of Chaos Monkey. So this is about how do you do the fault injection testing. This is also something good thing. So there are a lot of principles which there, like the Chaos Monkey is just says randomly you just disable the production system and see the whether your remaining system is able to do it. And there is other principle which says if your production system does not adhere to some of the best practices, some of security guidelines, then by default this principle says go and shut down the system. So these are the things, and we don't have to right away just go and try out these things. To be very honest, these are all something evolving. And Netflix, again, this is something coming from the Netflix. Netflix is the company who's already doing this chaos engineering in their production system. They were able to do a lot of experiments. If you are in the financial institution, we have something like a disaster discovery testing, right? Where you purposefully shut down your system and you will see some other system is able to do or things like that. So that is what it is. And probably the other topics is around the DevOps, or can we have a different thing? I don't what we'll do. I need 10 more minutes, guys. What is your suggestion?
Yeah, sure, Shiva, you can take. Is
Okay.
that fine, Shakti?
Like people might have some Q&A, so I was thinking about it.
Yeah.
Maybe like we'll take like 5 minutes for.
Okay, 5 minutes. Okay, great.
Unlike 5 minutes, we'll go for a Q&A. Is it fine?
Yeah, 5 minutes. I will try to complete. Okay, now so far I was
Cool.
talking about the microservice architecture principles and then chaos engineering, a lot of things. Now I'm going to talk about the DevOps. Okay, so DevOps is the another key phenomenon. If you are in the tech industry, everybody will say we need to move to the cloud. Okay, so the interesting thing which everybody should understand, right? In the on-prem solution, so the most of the cost. Okay, this is the report coming from the Gartner. Gartner is one of the industrial leader who comes in and says how the industry is going towards, right? So in the on-prem solution, if you look at it, only 44% of the implementation customization or the customization cost goes for, and then the remaining cost goes for the order infrastructure and then IT staff and then maintenance. But if you go to the cloud, 68% of the cost or the development cost goes for the subscription fees. Only the 32% goes here. So the problem or the statement what we are trying to say, if you are somebody who is just starting the cloud journey, you don't know how to use the cloud, then you should understand some of the thing like what sort of model that you are going to choose, what sort of the server, which region, what is your customer base, everything should be there. It is not, I mean, there is a principle there is a blind thinking that in the tech industry, if you move to the cloud, everything will be solved. No, actually, if you move to the cloud, you will end up paying a lot and you end up in a situation where you face a lot of issues. So that's why it is really important. You should start journey from small to the large, the things. Otherwise, you end up a lot of paying for the cloud, whether it's AWS, Google, or anything. The other one, with respect to the DevOps world, so there is a open source plugin that I just want to recommend. If you are following up with the Jenkins CI/CD pipeline for your all the microservices, right? So this is the plugin which will make sure that your build will not break in your CI/CD pipeline. Okay, so what that means is, what typically do, you have a feature branch, you check out a code from the develop branch and you check out a code and you work on some enhancement. Okay, in typical Jenkins CI/CD, what happens is when the developer done the changes, they will do a pull request for a review, and then reviewer reviewed. Now, when the reviewer click on the merge internally in the GitHub or the Bitbucket, what happens is the person who has done the changes, those source code will be sort of merged with the develop branch, and then from the actual develop, the pipeline will start. So the build will start, then the unit testing, integration testing, and if you have any quality check, then those things will done. Then actual deployment kickstart. But most of the use cases, what happens is in the actual development life cycle, all of us would have faced the issue that whenever we merge some changes, then the build will fail in the develop branch. Probably it could be code, it could be some code issue in the develop branch, or in the feature branch it worked, but in the develop branch it would have failed. And there could be some sort of a unit testing failure, or it could be some sort of a quality gate. There is a quality gate that team has targeted. We should make sure 90% of the classes should have the test coverage. So those cases will happen in the typical Jenkins CI/CD. So this as an unbreakable branch Jenkins plugin, what it will do is, if you try to integrate this plugin with your source code, whenever you are trying to merge the changes, instead of your feature branch changes goes to the develop branch, and then from the develop branch it starts the build, it will do a vice versa. From the develop branch, it tries to pull the changes to your feature branch, and it will start the build from your feature branch. So the thing is, if the build did not failed, it will not break the develop branch. It's not somebody has to come and do the fix so that the other person can check out the code in the develop branch. Typically, if you have a team where you are working you were working on the India and there are two in the US, and then the US team made some fix, they made some changes, and the build got broken. Till then they come and fix it. You have to wait for it, the committer who has done that. So that is the thing. Like if you are doing the CI/CD, I recommend you use this as an open source plugin, which will do some sort of a gated check-in for you to make sure. And then last part, I don't want to talk much about it. So again, this is also around the microservice. If you are in the microservice, you should automate your build and deploy everything with Jenkins CI/CD. Also, you should have a Docker and Kubernetes. Docker is like the very wider topic I don't want to talk about. And then Kubernetes is like, if you are running a microservices, how you are going to scale and how you are going to manage the containers. So everything you should know. So with that, I'll just stop. Any questions? And of course, these are all some references. I know last couple of topics I was not able to cover a lot of things, but at least you guys understood, right? What this industry does and what are the things they are moving towards. And if anybody has somebody would like to know in depth, okay, I did not understand, or you need more details, I personally recommend you to just reach out to my LinkedIn and we can have a discussion as well. So with that, I'll just stop. Any questions, guys?
Like they have like 2 questions in our Q&A box.
Okay, let me stop.
Let
me stop. Okay.
Like both are from anonymous attorney.
Does Kafka topic with multiple parts maintain the order of messages? Okay, so tell me about the service mesh, right? And I think I talked about it. Service mesh is like a infrastructure architecture for your microservices. How your microservice A communicates to the microservice B. That is what service mesh, and Istio is one of
Shiva, I believe you answered that question earlier itself. Like,
yes. So does Kafka topic with multiple partition maintain the order of yes, yes. Even though you have multiple partition, that will maintain the order of service mesh has values in routing. What about too many routing?
But I think Shiva, hi, this is Sunena. I posted the question on the order of the messages in Kafka.
Mm-hmm. Yes, please go ahead.
Yeah, so as per my knowledge, I think Kafka does not guarantee the ordering of messages between partitions. It provides the ordering within a partition, but see, I have read different things at in different articles. So could you please elaborate more, like in different scenarios, what will be the order?
Okay, that's a good question. So especially on the Kafka order of events, there are things that we need to little bit deeper. We should have understanding. I mean, theoretically, we can say a lot of things. For example, right? If you put a Kafka and there is a partitioning between the 3 partition servers, right? What sort of a partition logic that you should going to do? What sort of criteria that you are going to partition, and what sort of the topic that you want to partition? And within that, let's assume, see, there are two things you need to know. One is how Kafka internally partition and how that is internally intercommunicate with Zookeeper and how it is able to scale. And then the third one is you don't know anything about Kafka, or you don't know anything internal architecture, how it partition the data. Probably there is a Kafka which is already there in your infrastructure, and you are like a consumer. You don't know anything about it, and there is a topic as a end application. I just say you just subscribe to this topic, and whenever there is a topic, you just process it. So if you are at the end customer or end consumer, let's assume you are a Kafka topic consumer from within your organization, then you should know, or the person who is putting in the Kafka, there is a mechanism that you need to know what sort of order that they are going to insert, and there are things we need to deep dive into it. And the other one who is sort of owning the Kafka infrastructure, they know what or how many nodes that they need to partition the data. So that is something different. If still it is not clear, I would personally recommend we'll discuss offline. I don't want the other topic to get delayed, so I will definitely answer you.
Yeah, sure.
Is that be okay to take one question?
Yes.
Okay. Just quickly about the service mesh. You mentioned service mesh is about a proxy layer, right? Proxy layer around a microservice. Or microservice an API layer. On top of that, you are putting one more proxy layer, right? So is that be something similar to like you're putting your microservice in an APG with the proxy, and the other microservice also under APG and talking to each other? Is that something similar to it?
No. See, APG is like I mean, I don't know exactly, but I've personally worked on APG because I've for the last 3 years. Okay, I'll talk about it. Okay, APG is, from my understanding, APG, AWS, and there is a WSO2. Those are all like a API gateway. So how do you expose your API? I don't want to sort of have each API is exposed through a different domain and getting the certificates, right? For example, let's assume api.google.com. I'm just giving example. All the APIs, what are all going to be exposed through the Google is like a API gateway. What Google as is a API key. That is the API gateway that all the internal microservices is going to expose. There's the API gateway. There, if you go, what sort of authentication, authorization, documentation internally within your team, if they want to consume your microservices, then they have to go into the API gateway and they will subscribe to your application, and then they will access to your microservice. The point what service mesh is about the like infrastructure architecture for your microservices. So when the microservice A outbounds a call, like let's assume a server A, server B. Okay, server A is like a typical, let's assume laptop A and then the laptop B. Okay, so what typically happens is from the laptop A, you have written a simple program, and then from the laptop A, you want to consume the laptop B. So in the typical way, what happens is from the laptop A, you consume the laptop B HTTP public exposed API or IP, whatever it is. And then you get access and then you are accessing. So now what this service mesh say, from the laptop A, when you're trying to access, don't directly go to the internet. You just come to me. Come to me means come to the service mesh, and then service mesh intercept, and it sees, okay, you want to talk to the laptop B. Okay, then laptop B forward or that routes the request to the laptop B, and then laptop B internally access the service mesh, and then it internally talks. Now, what is the advantage here? For example, I don't know how secure you're talking about the REST APIs. There are a lot of things that we need to think about. You want to make sure your APIs are all SSL secured. There is a certificate import, everything there comes into the place. So if you don't do it in your Java or in your .NET, you need to have SSL certificate validation for the consumer to access. So if you have a service mesh, when the outbound request comes, and then within the Istio or Envoy, you will have those certificates imported, and you just make sure this domain is valid certificate, and this person who is trying to access is valid. And those are all the cross-cutting. You don't have to spend time, right? So I'm just talking about that, not on the API gateway like APG or the AWS API. Those are all the gateway for the API. If still need.
Yeah, I think I'm not going to
folks,
API gateway. Sorry,
like,
guys.
sorry
Probably
to
we'll take it
interrupt.
offline.
Like,
No problem.
we're running short on time.
No problem. Sorry about that.
Maybe let's take questions offline.
Yep.
Yeah, you can reach with me at any time.
Sure, please. Thank you.
Yeah. Thank you, guys.
Yeah, thank you so much, Shiva, for sharing your wonderful talk. And I hope this will be useful for the folks as well. Thank you so much.
Yeah. Thank you so much, Shiva. So
Mm.
like this talk, we saw like a lot about like microservice, how complex things are. Like next talk, we'll be seeing like how this has been achieved at code level. We'll take like a quick 30 seconds break.